Fantastic. Thank you.
So can you guys see my screen?
Yes, we can.
Awesome, cool. First of all, thank you for this opportunity. I really appreciate you guys inviting me here. So today we're going to talk about OPA and SPIRE, Decoupled Authentication and Authorization for Cloud Native Services. A bit about myself, I'm Ash Narkar. I am a software engineer at Styra, and I'm one of the core contributors and maintainers of the Open Policy Agent project. And so in this talk, I just go quickly over a high level about OPA, and then we'll go deep dive into the OPA SPIRE demo. So basically for OPA, the project started in 2016 at Styra, and the goal of the project has been to unify policy enforcement across the stack. We have a bunch of users and use cases for which OPA is currently being used in production. And it's a CNCF project with a bunch of healthy Slack community and contributors on GitHub. We are at the incubation level currently at the CNCF. So quickly, what is OPA? OPA is an open source general purpose policy engine. And when you use OPA, you are decoupling the policy enforcement from decision making. So your services can offload queries to OPA for policy decisions. So basically, if you have a service, and it can be any service, it can be a Kafka, a Kubernetes API server, or any other service, whenever it gets a request, it's going to ask OPA whether this request is allowed or not by executing a query. And then OPA is going to evaluate this query based on the policy and data it has access to and send a decision back to your service for enforcement. So we are decoupling the enforcement from decision making. And just to tell you, the query and the decision can be any JSON value and not just allow, denies, true, false. These are some of the projects OPA is currently integrated with. This is just a snapshot, and there are a bunch more than these. And so the cool thing here is you can take any of these projects and you can start using OPA with them without having to write even a single line of code to enforce Rego policies or OPA policies in your infrastructure. So I highly encourage you guys to take a look at them and try out these integrations. So now let's go into the demo for SPIRE and OPA. So let me set up this demo a bit. So in this demo, you're going to have a DB server. And this server is basically a healthcare application that holds patient records. And a patient record contains the patient's name, the patient's last name, and some sensitive information like social security number and the type of enrollee that patient is. We are then going to have 3 clients which are trying to retrieve this data from the DB server. And the reason we have these 3 clients is because they're going to help us in our demo to showcase different types of OPA policies and interactions with the SPIFFE library. Now, in a world without authentication and without authorization, like any service could talk to any service can get any kind of data, including sensitive data from the DB server, and there's no control over this. So I guess everybody on this call understands that it is totally not secure, and this enforces the need for strong authentication, meaning who is the entity, and for strong authorization, meaning what can this entity do. So before we jump into the demo, I just wanted to quickly talk about how OPA integrates into the SPIFFE v2 library that Andrew just spoke about. And essentially, OPA is going to use the listen and the dial methods which are provided by this library. And these methods help the clients and servers to form an MTLS connection using the X509 SWIDs obtained from the workload API. So the methods listen and dial, they have an authorizer argument which authorizes the client and the server given its SPIFFE ID. So this library, it already comes with the built-in authorizers that make authorization decisions based on the SPIFFE ID or based on a list of SPIFFE IDs and so on. But for more complex scenarios where the decision would be based on more dynamic properties, or if the decision is based on some external context, you need something more. And this is where OPA is a perfect fit as an authorizer for such complex use cases. So later, I'll show you all the code that I used to put OPA as an authorizer. But now let's jump into the demo. So the first policy that we want to enforce says that allow the privileged and the restricted client to form an MTLS connection with the server, and don't allow the external client to connect to the server on Monday, Wednesday, and Friday. So this is what it basically looks like. And so before we go any further, I just wanted to make clear, I have nothing against Monday, Wednesday, and Friday. I love all days of the week. In fact, Friday is my favorite day. But I just wanted to show the dynamic nature of the policy, and that's why I chose Monday, Wednesday, and Friday. So with that out of the way, I have the services which are part of this demo, like the DB service, as well as the clients already running on my machine. And I also have the SPIRE server, and I have the SPIRE agents running already. So all the workloads you saw before are already authenticated, and they already have a SPIFFE ID associated with them. So now let's try to demo this. So the first thing we'll try to do is we'll try to connect the privileged client to the database. And so what you can see that is the client which was privileged, that's the SPIFFE ID of the client. The connection status is created. It was allowed to form a TLS connection with the server because OPA as an authorizer allowed that request to go through. Now, similarly, if we try to connect the restricted client to the server, our policy says it should be allowed. And so again, you can see that we have a client whose SPIFFE ID is so-and-so restricted. And the connection again was created because OPA allowed the request to go through. Now, if I try the same thing with the external client, our policy says that the external client shouldn't be able to create a connection with the server because it's a Friday. And so now, if you look at that, the connection wasn't created because OPA denied the request. And so the question is, why did this happen? And so to answer that question, we need to look at the policy that's going on. Okay, so we have this OPA policy, and I can explain this later if you guys want. But what we have here, we've mentioned in this policy that Monday, Friday, and Wednesday are restricted days. And so that's why the external server wasn't allowed to talk or create an MTLS connection with the DB server. So just to show you the dynamic nature of how this is going to work, let's say Friday now is allowed, right? So I updated the policy. And so now if I try to make this connection again, hopefully the status is now created for the client external because OPA now allowed this request to go through. So let me change this back again to what it was. And now again, like I mentioned before, it's not created. OPA has denied this request from going through. So in this way, we have enforced an OPA policy in part using the SPIFFE ID provided by the listener during the creation of the MTLS connection. And I hope you guys saw what I mean. So we are checking here on the SPIFFE ID inside the OPA policy, and the input.peer ID, which is the input provided to the policy, is nothing but the SPIFFE ID that was provided to the authorizer by the listener interface of the V2 API. So let's look at another policy. So in the second policy, I'm trying to, so this policy attempts to demonstrate that OPA decisions can be more than Boolean. So as I mentioned before, you have a patient record, and it contains information like the first name, last name, and sensitive fields like social security number and the enrollee type. So the policy that we want to enforce says that the client, the privileged client, should be able to see all the fields in the patient record, while the restricted client should not be able to see the sensitive fields in the patient record. So we can think of sensitive fields like social security number, and we can think of sensitive fields like enrollee type, whether it's like a primary or secondary. And so now let's try to exercise this policy. So let's try to get data from the privileged service to the database server. And so you can see in this case that the data returned for the privileged client is all the patient records with all the fields exposed. Now, which is what the policy wanted us to do. If we try the same operation with the restricted client, as per the policy, the sensitive fields should now not be shown. So if you look at that now, it's the same patient record, but the sensitive fields like social security and enrollee type have been hidden from the restricted client. So again, the question now is, why did this happen? And to answer that question, you again have to look at the policy. And so this time, the server is asking OPA for the fields that are considered sensitive by querying this PII rule. And like I said before, instead of returning an allow, deny, true, false, OPA is returning a composite value, in this case, the list of fields which are considered sensitive. Now, you could have extended this policy to actually filter the entire data, but to keep it simple, I'm just returning the fields from the policy, and then the server application replaces them with the asterisk instead of the actual value. Now, again, to show you the dynamic nature of this, imagine that SSN is now not a sensitive field. So if you do that, and now if I try this request again, with the restricted client, keep a look on the SSN field. So the SSN is now going to be displayed because we changed the policy to say that SSN is no longer a sensitive field. And so one more thing I need to point out here about the policy and how it integrates with the V2 library is, again, this input.peerid, which is provided to the policy, is obtained from the server connection after a successful TLS handshake. And so the SPIFFE V2 library, it provides a method to get that server ID, get that SPIFFE ID from the connection, which then gets sent to the OPA policy. And so this way, you can write composite policies as well as simple allow deny policies using OPA. So that was the policy we wanted to enforce for a second demo. So now I have a question for the group. So what happens if the external client tries to get data from the server? And remember that the external client has already been authenticated. It has a SPIFFE ID associated with it. So anyone on the call venture a guess what will happen if the external client tries to fetch data from the DB server? Let's try out, I guess. So
someone mentioned depends on what day it is.
Someone mentioned on what day it is. Okay. Any other guesses before we try this out?
Policy.
Okay. So yeah, those are both valid answers. So let's just try it out again. So basically, if I try to get data again from the external server, an external client, which has already been authenticated, and try to get data on that, yes. So like you guys said, for the client, since the client, although it's authenticated, it's not authorized by OPA, and that's why we will not be able, or the client won't be able to get data from the server. So that was the demo. This is just the code snippet or the amount of code it takes to integrate OPA as an authorizer in that SPIFFE V2 library. It's a pretty minimal integration. It requires less than 100 lines of Go code. So I highly encourage you guys to check it out. If you guys want to see this full demo end to end, check out the link at the bottom of this slide. And so now we know that like we mentioned, the PB and J comparison here. So authentication and authorization, they both go hand in hand, and they are a perfect combination like PB and J. And so I hope after this talk, you can look at SPIRE and OPA in the same light. So this was a demo on SPIRE and OPA, decoupled authentication and authorization. If you guys want to learn more about OPA, check out the website. Join us on Slack if you have more questions about the project itself. And check out the project on GitHub. And if you like what you see, please like, share, and comment on the GitHub as well. Or please star the project on GitHub. And one final thing I wanted to mention was that we have an integration, like I said in the beginning, with SPIRE, OPA, and Envoy as well. So check out the OPA blog for more details on that. So thank you for this opportunity, and thank you for sharing your time with me today.
Great. So Ash, we do have a bunch of questions.
Okay.
I'm not sure do you have the chat window open next to you, or would you like me to read a few out?
I'm just looking at the chat window right now.
As you go over the questions, Ash, I know you're among the first to try the V2 of the go-spiffe library. Can you tell us a little bit about your experience with it? What are some of your impressions? How easy was it to work with?
I thought it was super easy to integrate OPA as an authorizer in the library. Like the methods, the TLS methods, the listener and the dial methods were super convenient to use in my application. And like integrating OPA with those as an authorizer was like, it's super simple, and it is not, and obviously the team helped me a lot on Slack. So I really appreciate all the help Andrew, Madhu, and the entire team provided. But getting all this together, getting this patched into the new API was a pretty simple process. And yeah, and it went on pretty smoothly, as you see in the demo as well.
Well, good work to you on piecing it together. It was relatively very short time also.
Yeah, happy to do it. And again, thanks to the team for helping me out on doing this.
Yeah, I really appreciate it. I think the first question is there a graphical portal for policy management?
Is there a graphical portal for policy management? So the open source OPA does not provide you any kind of UIs. That's something that we do at Styra on the commercial side. But we have a Rego playground, which is play.openpolicyagent.org. If you want to like experiment with policy and if you want to try out and share your Rego policies. So that's something that's in the open source, which is play.openpolicyagent.org if you want to try it out.
Okay, great. I think the next question is probably around SPIFFE. I don't know, Andreas, if Andreas, you or Andrew would want to take it, this one. It talks about, is there a way now to identify the bare metal or virtual workload early at a PIXE boot time? Does it still require HSM and TPL modules? So I'm not sure if that's a question for you, Andreas, or for Ash. Andreas, you're on mute, I think.
I am rereading the question. Generally interested in the SPIFFE project, way to identify their bare metal or virtual workload. So if you look at SPIFFE, fundamentally, the problem we're solving is how do you identify anything that's new, be it new software, be it good new hardware. How does this that just popped up in your infrastructure is something you can go from, I've never seen you before, I have no idea who you are, to, hey, I know you very well, here's the level of access you now have. There are plugin extensions that were showcased at the last community day around TPM at the station. That's certainly a way to identify hardware and bootstrapping. Andrew, not sure if you want to add anything to that there.
I guess my only thought is that identifying the workload at PIXE boot time isn't, I'm not sure that we have the right things in place to support that right now. I'd be super interested in exploring that offline and hearing some more requirements, or exactly like getting some more details on the flow there. It's not quite solidified in my mind based on what details I have right now.
Yeah, Centaurs, and if you're using Ignite or whatever bootstrapping mechanism native to CoreOS, happy to talk that through if you're looking at things like measured boots, or what within like a bootstrapping sequence would you be looking to measure.
Okay, so
I see question around, does SPIRE talk to authorizer after the connection is established too? This is in regards to how does the PII filtering work? So in this case, we wanted to show two kinds of integrations, one at layer 4 during the actual connection. That's where the allow rule was used by OPA. But for the PI filtering, that's something at layer 7. So that's something that the application has to call OPA and get the filtered fields back. So two different kinds of integration, one at layer 4 using the LTS, the new library, and one at layer 7, which is, we've typically seen this before as well with OPA.
Great, thank you.
Hey Ash, can you go one level deep and explain how the data masking works?
Sure. So like I said before, OPA can return any kind of JSON data. And so in this case, what happened is OPA, when we queried a particular PII rule, and based on whether the body of the rule was true or not, we returned a list of fields. And the list of fields that was returned by OPA was like SSN and enrollee type. And then the application, what it did was it replaced the actual value with the asterisk that you saw. That was to keep it simple. But you could have also done the actual filtering, meaning you could have got the filtered list from OPA itself using stuff like object comprehension and array comprehensions, which OPA natively provides. But that was a bit advanced for this demo. That's why I didn't show that in the policy. But you could definitely get that list directly from OPA itself instead of the application doing some manipulation on it. I hope that answered that question, Nitin.
Thanks.
Thank you. I think Ash, there's one more question from Yogi, I think. Can I also control writes and reads wildcard entries for a role?
Can I also control writes, reads? Can you explain this a bit, Yogi? It's not very clear to me what you mean.
Yes. In the PII, just taking an example, you did restrict a couple of fields, right? So in this case, it's completely read. So
Yep.
I was kind of trying to analyze if I could even control like writes, or maybe kind of go to the higher level, something like Apache Shiro project has, right? Where you have this canonical access roles. So that was, I mean, it's a twofold question. The first one is, we did, in the demo, you did show the read roles on how you actually read multiple fields. What about writes, right?
Yeah, you can definitely do writes as well. Because like I said before, OPA takes any kind of JSON value as an input. So in this case, the method was get, and we were doing it on a particular role. But you could give it any kind of input. You could give it a put or a post or whatever it is, and then you can give any kind of role or any kind of RBAC that you want to have for your own policies. You can give absolutely anything to OPA, and it can give you a decision back for the PII or whatever it is. So yeah, just to keep it simple, we just kept it with simple gets and a simple peer ID, because we wanted to focus that the peer ID is coming from the listener connection. But yeah, you can give it any kind of data, JSON you want, and write your policy on that, for sure.